ओके सो आज हम लोग सॉल्व करेंगे लीड कोड क्वेश्चन नंबर 33 इन विच वी आर गोइंग टू सी रोटेटेड एरे। वो मैं बताऊंगा कि रोटेटेड एरे क्या होता है एंड देन आफ्टर क्वेश्चन बेसिकली क्या है कि एक अपना एरे है विच इज़ रोटेटेड एरे, ठीक है, सॉर्टेड एरे, ठीक है, एंड उसमें एक टारगेट एलिमेंट है जो हम लोगों को फाइंड करना है कि वो कौन से पोजीशन पे है, कौन से इंडेक्स पे है, एंड इंडेक्सिंग इज बेस्ड ऑन जीरो इंडेक्सिंग, राइट। सो लेट्स फाइंड आउट कि कौन सा इंडेक्स पे है, लाइक जीरो इज द एलिमेंट, जीरो इज हियर, सो जीरो 1 2 3 फोर्थ इंडेक्स पे है, सो द आउटपुट इज फोर्थ। एंड जब तुम एलिमेंट नहीं तुम्हें मिलेगा उस पूरे एरे में, so what you have to print is -1, okay। So like see, target is 3 but there is no such element in the array, right? There is no 3 in this array, right? So the output is -1, okay। So we can do this by basically two methods. The first one is linear search and the second one is a binary search, but it's written like 0, like O of log n. So basically it's binary search, right? So just see like what is the question basically, right? So first let's just do it using the linear search, okay। So by linear search we'll do let's say we're using a for int I equals to 0, which is an iteration. Then we'll set the uh, like how many times the loop will run, and then the increment, and then after we write a condition, okay, if the num of I, which is the array का element, right, वो अगर equals to है target के, then will return the I, which is the index, right, or else will return -1, right? So let's just submit this thing. Compilation, oh sorry, it's nums, right? So let me see, it's accepted, right? But the complexity is O of n because we're using a single loop here, right? But we need to do this in a single what's say O of log n, right? And why it's O of n is just because of it's like iterating through every number. Like if let's say what we are searching, like हम लोग जो खोज रहे हैं वो element is at the last index, right? So we have to go through each and every element to search for that number, right? But right now we are going to see a totally different solution using binary search, okay? So first let's understand what is binary search. So binary search is nothing. Let's say there is a sorted array 1 2 3 4 5 and 6, okay? So there's an array, and what binary search do is, let's say our target is like 6, okay? So we have to select two indexes, like we have to use this one, this element and this element. Then what we need to do, we need to find the middle element. Let's say middle is the 4 one because we always use like +1 to get that element, okay? And then after, like we'll compare that. Let's say target is 6, so we'll compare like middle element, that element to the middle element, like 6 is greater than or equals to 4 or not, okay? So it's greater than equals to 4, right? So we'll shift to the right side, okay? We'll leave this thing, okay? We'll go to this side, ठीक है? Then after what we'll do, हम लोग basically then यहाँ पे भी same चीज़ ही करेंगे. Now our left index will be 4 and we'll search the middle of this one, okay? So the middle will be 5, right? And then after what we'll do, we'll see okay this is equals to or not, like great, sorry this will be like this, sorry, is less than or greater than, ठीक है? और यहाँ पे सेम चीज़ होगा 5 से, so it's true, right? It's true. So we'll move to this side, and then after there will be only 2 elements, and if it's greater than 5, so obviously the only element is left is 6, right? So how many iterations there are? The first one is we have to use like half of the array, like 2, and then in 3 iteration we got our element, right? But in linear search what we used to do, we used to iterate through every single digit. We have to go through this. So this is how binary search works basically, right? We will have the array, then after we'll match the element, like if it's greater than the middle one or the lesser than the middle one. So if it's lesser than the middle one, we'll go to the left side, and if it's higher than the middle one, we'll go to the right side. Then we'll do half, and then we'll do the same and same until we find our element. Okay, so let's implement this. Okay, so now our linear search is done. Now we are going to perform binary search, like what the solution, what solution needs, right? What this question needs is like binary search, right? So we are going to do that first. Okay, so now let's understand like how the binary search work in this rotated sorted array. Okay, so what is a rotated sorted array is nothing but the array is sorted. When you'll see from there, so it's sorted, right, but the positions are fumbled. Okay, just like we will shift some elements together to the left or right or whatever, right? So this is the rotated array basically. Okay, now what we are going to do is we are going to take two elements, like the first one is here and the second one will be there, and then we'll find the middle one as I said previously, right? And after that नाउ द मेन थिंग इज़ कि अपने को साइड्स देखने की, जो अपना टारगेट है कि अपने को साइड्स देखने की, विच साइड फर्स्टली विल सी विच साइड इज सॉर्टेड. Okay, so we'll see the left one is also sorted too and the right one is sorted too, right? So now we'll go and find like which side is the target element, right? हमारा target element किस side है, we need to find that first. Okay, so we'll see like this is the maximum element, we'll go to this side. I'll show you in the code like how it works basically, right? And then after we'll choose this as a left one and this is the right one already. So okay, so there are three elements only, right? So again we'll find the middle one, 0 and 2 1, and then after we'll see like 0 is greater than or less than 1. So it's not true, right? Like if it's not true, then it will be in the left, or if it's true, it's in the right. It may vary, but now it's working like this. Okay, so it's like here. So we'll move to the left and we'll match that element, like target equals to left of whatever, left of I or whatever is like work, it's true or not. If it's true, then we are done. It will be done in 3 steps, mostly 3 or 5, 3 to 4 iteration mostly. Let's see. Okay, let's solve it out. Okay, so let's start with the coding and all. So yeah, let's series this thing and start from. Okay, so let's say we are using 2 pointers here, left equals to 0 and right equals to nums dot size minus 1. Okay, nums dot size minus 1. And what we're doing, we initialize like two pointers, like the left one and the right one. Okay, the left one and the right one. Okay, and then after we are doing a condition like till when our loop should run, which is basically a left pointer should not be greater than the right one. Okay, now we are going to calculate mid, and mid equals to left plus right minus left by 2. Okay, now this is basically for calculating mid. Okay, now we'll see if the mid is equals to the target or not. Okay, so nums of mid is equals to target, and what will we return? We'll return mid. Okay, now let's go and let's see which half is sorted. Okay, so now num left is lesser than mid. Oh sorry, nums of mid. I'll explain each and everything. Okay, don't worry. Okay, now if now we're seeing like which side is our code. Okay, like which side is our target element. So target and target is, should be lesser than the nums of mid, and then after it should be right equals to mid minus 1, and then after else left equals to mid plus 1, and then bigger else I'll say like this else, right? Yeah, this else if the nums of mid is lesser than the target, and then target is lesser than equals to nums of right, and then after we'll perform left equals to mid plus 1, right? Mid plus 1, and else right equals to mid minus 1, and if nothing is correct, so we will just return -1. Let's see if there is no compilation error or something. Should pass, right? Compilation error, end. It's not sure. Well, it should be int, right? Int. Yeah. So again I'm using nums. Yeah, it's accepted. Let's submit it. Okay, so now the complexity is O of log n because we are using binary search. Okay, the complexity of binary search is O of log n. Okay, so what we are doing here, we initialize 2 pointers. Okay, the first element, like the initial indexing, like this is 4, and then after this is last one, and then after we'll choose a loop. We'll start a loop basically. And loop is for like if basically is for कि left element जो होता है, left should not be greater than the right one. Okay, and then after this is basically condition, right? And this is when we'll learn binary search, you'll understand why this works. Okay, and then after mid, we're finding the mid. Okay, mid elements. Okay, so there is the mid one is 7, then we're finding like if the mid is equals to the target or not. Okay, so it's not. Okay, then we are searching, we are going for the left of the array, like here. Okay, that thing is sorted or not. Okay, that is sorted, right? We'll see that if it's sorted or not. Okay, then what we'll do, yeah, we are going to the right one. We are going here, okay, in this one, and we are searching for the elements. Okay, what we are doing, we are going for the nums of mid, and like if the element lies between nums of mid or nums of right. Okay, if it's there, then the answer should be left equals to mid plus 1, or it should be right equals to mid minus 1. Okay, and then at the end it will return mid only. Okay, because it will be whatever the output will be, that will be on the mid only. Okay, this is how binary search works basically. Okay, so thank you for this.